You've chosen the presentation for topic 4, building pathology. This is a part of the subject building life cycle maintenance. This presentation isn't to replace the study guide for this topic, but merely to act as a summary to assist you further in your studies and maybe give you a different perspective on the subject. Building pathology. It's a term that's not readily used in the property and construction industry. So I've put here a definition of how it could be perceived. A detailed knowledge of how buildings are constructed, used, occupied and maintained, and the various mechanisms by which their structural, material, environmental conditions can be affected. So as buildings move, materials which they're made of, they need to be ventilated. Materials slowly deteriorate. Eventually, buildings become dilapidated. And as we looked in the previous topic there, we need to make some decisions there in its life cycle, whether it requires demolition or whether it requires refurbishment or rehabilitation. Now, building pathology really is concerned with the identification of those building stresses and deterioration, analysing the faults, and from experience then, identifying the appropriate maintenance that's required to bring it back to that required service level of delivery. So if we consider the building as it stands in its daily operation, there's a lot of environmental issues that impact on it that, as I said earlier, stress the building, make the building deteriorate, and these stresses interpret how the materials, the structure, how it responds, and whether it can still deliver the service level that we're looking for. This diagram here, it very simply shows us those areas that impact on the performance of the building and that determine if there's likely to be a pathology problem with the building in its maintenance and where maintenance needs to be specified. I've identified here the 4 main areas: is location, site and external environment. So that's simple. That can be a coastal environment, there could be an area in a high acidic industrial environment. The external envelope, this is extremely important. How the roof, how the external walls, windows and doors, how it responds to the weather, the moisture. Once we start letting moisture and the building's not weathertight, we've got additional problems, not just the waterproofing and the sealant of the external membrane or the external envelope, but we've also encouraged internal problems, maybe rising damp, maybe termites, maybe rot. The structure and the fabric, how does that hold up? How does it hold up over time in the specific site it's on? Does it break down because of, again, the type of conditions subject to the site? Does it deteriorate because of the type of usage, or is it deteriorating because of a combination of the 4 items summarised here? And fourthly, the building services. Is there issues there inherent to the services that are installed in the building that make them susceptible to further deterioration or additional work and investigations required in areas of it, like filters, like ductwork? So some of these issues with pathology, it's very clear there's a real visual impact. I've provided some examples here, that some photos which I've picked up over time, and it's very clear once you look at it that these are really deteriorating rapidly. It's likely to impact on the service. It's likely to impact on the life cycle, the longevity of the facility, the building component, or even its service to its tenants or customers. And so these types of building deterioration require additional maintenance, additional investigation as a part of maintaining the building. Often with plant, equipment and buildings, it's advisable to have random spot sampling or random audits of more detail to look at components and how they're actually responding, behaving, and whether it's the right maintenance level. Now, these type of audits might be at different levels. They could be at levels where you bring the plant out of commission, like in this case here with the pool, it's emptied, to actually fully understand the status that we have, so that we don't get to a situation where the deterioration is so bad that it puts the service or the building totally out of commission and totally out of use. So it gives us a good understanding on how the building is actually performing and where the likely hotspots of deterioration are going to be, so then we can start funding, or then we can start life cycling accordingly. I like to consider this method and approach to maintenance, the economics of maintenance and the quality control of maintenance. And in these cases, as the pictures I showed in that previous slide, it comes back to all the time the design, the construction detailing, which is also the commissioning, the quality of when it was completed, the maintenance management. Is it sufficient to achieve the quality required? Is it sufficient to ensure that there's no outages? Is it sufficient to ensure that the material, the product, the installation achieves its maximum life? And then the building management itself. Is the building management being fair? Is the occupation of the building, and is the use of the building or the facility or the service, is it within the original design constraints? Are they overloading it? Is it over-occupied? Is the time clocking more than what it was originally designed for, or was it more than what it was originally intended? So the biggest issue when we're looking at building pathology and issues associated with deterioration on a pathology basis is to try to identify the process that created the problem that we're looking at. This is a simple, I suppose, decision-making process that you might do in your head, and it shows when we're looking at the outside of a building and we can identify a horizontal crack that's been formed on the external wall. There's a number of different decisions and questions that we need to ask ourselves. Is it as a result of movement of the building itself? Is it got to do with being adjacent to another construction? Is it a result of having insufficient heating installation, or is it too much sunshine loading? Is it a result of processes adjacent to the building that is causing the crack? So whether the crack is more as a result of operation, or whether it's actually a part of poor quality in design or poor quality in build. So these are questions that always need to be asked to see whether this issue of deterioration, of whether it's an isolated incident or whether it's something that may be impacting the whole of the external facade of the building, and that we need to make further allowances and further audit or further investigation so that it doesn't create a bigger problem, a bigger liability for the overall building, as in cost, as in downtime, as in, again, possible loss of tenancy or possible loss of use of the building. Now, one of my favourites when considering pathology is, as I've said in this slide, the poor old multi-storey car park. It's a building or an asset which is usually designed constructed, and really left to its own devices. And interestingly enough, it's a building or an asset which is subject to all the rigours of the environment, including oil from cars, including a lot of movement, so it needs to be quite an articulated, movable structure. And having said that, they're nearly always concrete as well. So in this particular multi-storey car park, this was a building, a structure, which I'd actually looked at myself. There was a number of different things. There was water ponding, there was concrete cancer, there was cracking, and some of these things you'd think, well, Okay, that's not so bad. It's only a bit here or there. It's only a small amount of damage. That's not going to be a big problem. But funny enough, it's a massive problem. Chunks of concrete falling on cars, stains from the concrete, from calcium and lime coming through, rust stains coming through and falling on cars. Major problem. So considering how the building's responding and looking at the isolated areas where the building or asset's starting to fail, and then saying, well, is this a problem everywhere? And then responding to it correctly to ensure that the asset or the building is safe, is secure, and is not going to deteriorate. And if it does, then you have a plan in place to rectify it. I'll discuss rating tools in the next topic with building auditing, but I think it's important to just be aware of them here as I'm talking about looking at, say, the car park, which I had a photo there and discussed before. Is that when we're looking at these particular failures in the building and pathology problems, it's important to risk rate all of them and condition rate all of those. That way it'll identify to us when we look at the structure in its entirety, where are the real problem areas? Where are the problem areas that we really need to focus our resources, our time, our money? And what are the areas that are likely to cause us problems that we need to then start to project plan decommissioning parts of the building or the asset while repairs are carried out? And how can we work around that? How can the asset still keep functioning when it's only functioning at 80% capacity? So risk and condition rating is really important part of the assessment of the building. So if we look at a simple example, going back to the car park, of what our notes might look like on a site inspection and looking at those specific areas of deterioration, it will look something like this. I've itemised out the item number, so each specific problem I found in a report, a written report with a summary, evaluation, and a list of considerations for the client, reference point, a description of the defect, so it's showing their capping blocks on block wall balustrade cracking, floor slab deteriorating, those type of things, a location of the defect, so that can actually be identified back to where are we going with this. Quite often I like to support that with photos as well, and maybe a marked up drawing. The possible rectification options, that makes it useful for planning and pricing, the priority of the work, and then, as I said in the previous slide there, a condition and a risk grading, which is very important for later on. In software and Excel programs, then we can start sorting that to identify all the risk ones, all the condition ones. In the last column, it's very useful to put an indication of cost, you know, whether it's a $1,000 problem, a $10,000 problem, or a $100,000 problem. Straight away we can look at whether this is an issue that we really need to identify very early, because this is going to get out of control, or otherwise this is not something we need to do now, but it's something that we really need to keep in reserve. It will become a backlog, as we discussed in the earlier topics. Sometimes there's issues which may be cosmetic, may not be a problem to the short-term function of the asset or the building, but long-term we need to do something, but we don't need to do something this year. Okay, we've come to the couch end now of this topic, and it's a good opportunity for you now to review this topic, read over the study guide, refer to the subject text and readings for this chapter and this topic. Once you've done that, work through those workbook activities, and if you've got any questions at all, post it to the student forum, or otherwise send me an email.